How are you, Selma? Okay. Just a moment, please. Okay. So can you see my screen right now? I cannot hear. Adel, can you use the mic? Adel, can you hear me? Engineer Adel, can you hear me also far? Okay, so let's get started. I believe you can be here with so far. In case of any network fluctuation, maybe something missing, feel free to use the chat. And okay, just type two or types that we cannot hear you well, and I will stop for any clarification. Okay. So again, I'm very pleased to be for you at this second session for me. The first session was regarding Imbal, and now we will talk briefly about well test pressure trans analysis, how to have a quick look about the Sapphire, how we're gonna use it, and some theoretical concepts as we normally do. So let me sure that you can see my screen right now. Is everything okay? Yes, yes, yes. Okay. Good luck to know. Yes, okay. Okay, guys. So, uh, does anyone has any experience with Sapphire? Because this kind of version, which is the volume of 5.4, it will not be available unless you are working in a company, or you can purchase it, but it's somehow expensive. So I think for you guys in the internship, we may try to share the old version because this unfortunately is not for shared. We cannot share it because it is linked to each PC ID, so it will not work except for my PC only. So do you have any experience with well test? Because normally people have experience or students have experience with well modeling, material balance, but for this kind of well test, PTE or RTE, rate transit analysis or pressure transit analysis, it seems that you somehow lack the experience. So did anyone make any modeling in well test before? You can use a chat if that's yes, or you can mention the name of the modeling or so on. Guys, can you hear me well? If no, you can say don't be ashamed. You can say no, because many engineers right now still don't use well test Sapphire, and especially if you are working with offshore. if we are working with offshore, it will be very challenging because due to the logistics and so on. Because in well test, you need some time for shutting your production and so on. Okay, so I will go briefly because actually we have around 1 hour because there is an important webinar 1 hour and 15 minutes from now, and it's very important, and I encourage you all to attend this webinar because it's directly related to the reservoir and seismic, so it will be something very helpful. Okay, so let's start. This is the screen of the Sapphire. Very simple. I will start mainly by opening an already existing project to see how we can look about the main windows. And after that, we can try to make like a very quick scratch, a new project to see that what are the simple steps you need to be aware of. And regardless of the version of the software, whether either this version, the latest version, which is 5.4, or even the old version, it is the same workflow, the same procedure. It is just some tabs and some new features and some changes in the appearance itself. But the process and the workflow, it would be same as this late version. So simply this is the Sapphire will test. I will switch to the presentation normally as I do to have some concepts, but after getting familiar, your eye getting familiar with the software itself and the process and how we got it. Okay, so we have here like a module, so you can simply open. Again, we can start from scratch. You will have here your software. Let's say here as a search, we use Kappa. So I had to have the 5.3, but it's now non-valid. So we'll go for the upgrade version, which is this 5.4. We will click on it because it is Kappa package. It has around six softwares related to PTA, RTA, and so on. So it takes some time to open. So yes, now it's okay. So we will go to choose that we can see Sapphire here, and here is Tobas for return analysis and some other softwares for simulation and Emberit for PLT and so on. Uh, let's start with Sapphire. This is our main objective in this internship to get you familiar with the well test analysis and how the bunch of data you can get from such this kind of tests and how to look at data and so on. So it normally takes some time. Okay, so this is the interface of the Sapphire. As you can see, you have like simply can make your new project from here, and we're gonna test it. But after opening an already existing uh, will test module, so let's start with this basic will test example. Here, just you can open it. Normally, this kind of software, especially the upgraded ones, you will suffer from some kinds of fluctuation due to they make some luxury, and not all machines can accept all of this. So this is your first insight of any well test analysis. As you can see, well test in its simple meaning is that you are make a disturbance in your well. Just this is the simple meaning of the well test. You are just making a disturbance. What does I mean? Or what do I mean by making a disturbance? It's that if your well is flowing, so you're gonna shut in. If your well is shut in, so you're gonna make it flowing. So the transformation from status to status, from shutting to being producing, or from producing to be shut in, this is what we call disturbance. And I've been using high resolution gauges. If you're gonna use a normal gauges, so that forget about well test, because well test mainly is dependent on using high resolution gauges so that you can detect every change in the recording or the pressure recording, so that we can have something like the fingerprint. Your fingerprint is unique. So I have a fingerprint, you have a fingerprint, and so on. So the same situation for the reservoirs. You have you have some fingerprints corresponding to some features or parameters or something like this. So if I can see this fingerprint, I will see that this is a vertical one. If I can see another fingerprint, I will see this horizontal one. And for reservoir, if I can see this fingerprint, I see that this is high permeability reservoir. This is low permeability reservoir. This is radial flow reservoir. This is infinite acting reservoir. This is a very limited volume reservoir. We can see a boundary. I not see a boundary. There is a skin or not. All of this depending on recording the signature or the fingerprint of this disturbance wave we already create. So it mainly depending on creating a disturbance. And the second point is that you shall have like a high resolution gauge to record this event. If you cannot record this event, so it will be like a pressure static measuring a pressure in a normal way. It's not about voltage. So the first step in wall testing is that loading your data, and here are already loaded. Simply, you can see as here, you can maximize it. I think you can see it now clearly. You can see here, this is a recording of the rate with time. It seems that this will has been flowing for around 15 hours. And we decided to shut in the well. So the rate now is 0. And we began to record the pressure. Here is the recording of the pressure, as you can see. And you can see that we can make like some kind of zooming. As you can see, here is like a very synchronizing between starting of the pressure and starting of production to be 0. This is very important because in some cases you may see that there's like some kind of shifting. So we need to correct for this. Okay. So this is the first step is that to visually inspect or QC your data. You can see synchronizing between pressure and rate. You must know or you shall know your rate from any other well testing device, multi-field device, or something like this. So please don't go and to perform your well test analysis and you don't know what's your well is producing. So you have to determine first the rate of the production, because if when you're gonna stop the production or make it 0, so you know what is the previous production, because it is an input, as you can see in the software. Okay. And see your pressure, you can see that I can see the pressure, and also I have like a QC or range from, for example, here we can see that around some, here you can see the value of the pressure, and you can see the building of this pressure can going up to around 4,000 psi. So it's mainly also depending on your understanding of your reservoir and your area. That's why reservoir engineers are the one who are responsible for interpretation of the well test, because it's not a solo task. You shall have like a deep understanding of your reservoir and a good integration with other disciplines, especially the G&G team, because from the G&G team you will get some useful information about the mappings, area, the structure. So you can see, yes, in this area we have a homogeneous reservoir, we have a heterogeneous reservoir, we have a fault, we don't have a fault, we have a barrier, and so on. And from your deep understanding of your reservoir and your production performance as a wells, you can determine, yes, we have a strong aquifer pressure supported, we don't have a strong aquifer, and you have other tools like PDT and so on. So you can determine what is the signature or the behavior of your reservoir and implement this in your well test analysis. So this is simply the first step, as I mentioned. The good thing about Saphir is that the process is normally going from up to down. So you start from loading your Q, which is the rate, and this is the rate, loading your pressure, which is the pressure, and they begin to extract. What do we mean by extract? Here is just an input. It's just like you are recording your data, dump your data into your hand, into your Excel sheets, and you just load it up or upload to the Sapphire. Sapphire has, or the software has some, as I mentioned, characteristic curves. We will see this right now, and already he is capable of extracting the derivative. As you can see, we'll go to the extract. My main point is the derivative. As you can see, here is the extract. Here is the pressure. This green line we already saw it before. You can see this one, this one. Okay, or no problem. The point now is that creating this derivative, because this derivative is the one we will do much work on it and trying to matching and to see the fingerprint signature and so on. Okay, is it okay right now? Is it okay? Is everything okay right now? Do you have any problem? Do you have any question before proceeding? Great. That's great. Okay. Shahab, Ahmadu, that's okay. Do you have any question before proceeding so that I make sure that you are somehow familiar with what you can see on my screen? Okay, so let's continue. Okay, so I think, as I said, this is the second step, one of the main steps, as I mentioned. Uh, this is called build-up test. Yes, yes, yes. Again, this is a good question. Yes, yes. Okay, again, yes, yes. This is yes. We are no, why? I will tell you why we are normally going with build-up in my slides. But take it right now is that we want to have like a stable rate. And as I will show in the PPT, we cannot assure a stable rate. But zero rate, actually, it's a stable rate because it's a zero, even if it's zero. So, but it's stable. It's a stable number. I cannot see 0, 1, 2, 3, 0. So it's a zero. So it's a stable rate. That's why I prefer to go with this one, where is the will shut in, zero rate, stable rate. So this is the building up of the pressure. And yes, as you mentioned, this is called the build. Amir, this is the build up test. Yes. Okay. So again, we'll go to extract the derivative. Okay. Here is he just asking, reflecting back to the Amir question. If you have, yes, as I told you, Ahmed, that BBU is related to we want to have a stable rate. Yeah, I want to use a derivative. We want to have a stable rate, and if you are if we are following the wall, we are not sure that it's a stable rate. We want to have multiple tests, multi-phase device to have testing for the well and make sure that the well is already, especially in depleted reservoirs. So the solution to this issue is that making the rate zero, which in other words means that you have a stable rate. That's why we prefer the build-up. Okay. What is the importance of the derivative? This derivative uh, is the one that we will trying to match. And here is the hidden secret of the. It's not a secret for sure, but here is the hidden mathematics about the signature, because normally the derivative is more resolution than the normal pressure trend. The derivative mainly, derivative is like, simply distance and time. So the derivative of distance and time is the velocity, and the derivative of velocity is the acceleration. So the derivative is mainly is concerning with the change. So changing the distance with time, it's called the velocity. But the distance itself, it doesn't have a meaning, or time itself has done a meaning for us. But when you can see that there is a kind of a change of distance per unit time, so now I can compare between this change and unit change, and I can say that he's faster than me and something like this. Okay, so this is the importance of the derivative. So the derivative is mainly considering with the change, and if you're gonna make a high resolution change, so it means that you can detect more parameters. And that's why initially I told you that one of the main key points to have a successful representing voltage is to have a high resolution gauge. So the physical gauge you will use to report this data has a very important advantage. Okay, if you don't have a good gauge, you will not have a good representing data. So not a good derivative. So not a good fingerprint. Okay, is it okay now? That's okay. Anta, Ahmad, thanks. Okay, thank you. Okay, so reflecting back to the question, if you have different intervals, uh, let's say that this is like one interval of flowing, one interval of shutting. So let's say that you decided here to open the well again. So you will gonna open the well, you will have like time of production, then you can shut in the well again. So you will have in this situation you will have two flowing periods and two building up periods. So here you will decide. He will ask you which interval to choose for the production and for the gauge. If you here if you have uh, more than one gauge, and normally we use one more than gauge because as I told you the gauge is very important. So we don't want to lose a job totally if we lost the gauge. So we normally go with two gauges to be backup to each other, or if we have some issues with gauge one, so we can depend on gauge two. That's why here he will ask you about which gauge to use, but here we are using just one gauge. And after that, he will tell you which production period you're gonna use and which build up period you're gonna use. If you have different build ups, we can use one and we can repeat the test on the second one and make like something of like quality check. So because I shall have consistent results. So I shall have when I make analysis on the two periods, I should have the same parameters unless there is a short build up period and a long up period. So we normally prefer long up periods because long time period, it means that long disturbance and means that high resolution derivative so that I can detect the parameters. But actually, in operation and in management decisions, they don't want long time PPU. Does anyone know what is the reason they don't like the long time well test? Does anyone has any does anyone has any idea why do managers don't prefer to have long time build up test while we as reservoir engineers prefer to have longer time to see more information. So what do you think? You can use a chat. You can use a chat. No, no worry. Losing, yes, exactly. That's it. Yeah, we are losing production, especially for high rate wells. So yes, that's great. So now, yes, you decided that yes, we will use this kind of gauge, this kind of production, this kind of build up. Here, normally we don't make something unless you have some discrepancy in your data. So we introduce a term called smoothing. Smoothing is something related to data, but normally we don't prefer to use it because smoothing means that you mask your data. I don't want to make a smoothing because I want to see the data in its actual phase. I want to see something like this. As you can see, it is like something losing or something discrepancy because I want to make my interpretation. Okay. I'm sorry. So here we will say okay, and we will let him to loading. As you can see now, it's loading. Here you can see. So can you see this wall? I think you can see. Here is my history, which is production pressure data, no change. And here is the derivative I'm saying. As you can see, here is the derivative. Okay. You began to make the derivative, and people who are accustomed to well test, they know that here is the area of what we call the well for storage, and I will mention it in the PPT right now. And this hump, we normally relate to the skin of the well, and this time, this interval, it normally related to the reservoir performance. And if you have a long time build up this, you will go to the boundary condition to determine the boundary. What I mean by boundary, do we have a fault? Is this reservoir is very big, so this line will be continue horizontal. You cannot see a boundary. Is this line would be like died, would be going down died because no more volume, so it's closed boundary, limited, and so on. So, and here is the normal Horner plot. You can see this is the Horner plot. Horner plot. I will remember you something. I think you take it in your college in your faculty. I think you can. I think you can remember this line. I think you remember this line. This line of Horner. Do you remember this line of Horner? Horner plot. This is the Horner plot. So, this is. I will tell you the importance of this one. Something like this. Okay. This is the Horner plot, and from Horner plot, which is coming from this derivative, we can determine these parameters. You know, we can mainly the permeability or the KH over mu, and as you will see that mu, which is the viscosity, H, which is the reservoir thickness, it's already an input. So when we make a product for the weld test, we already input our viscosity because we know our fluid, and we already input our thickness because we know our reservoir. The thing that we don't know is the permeability. So from this Horner plot, from this upon having the data and upon having this kind of normal plot, you will be able to make your analysis and have your permeability, which is one of the main advantage or the main features of having a weld test. So if you're gonna maximize this one, okay, as you can see, this this black dotted, it's a feature from the software. You can use it, drop your mouse, and you can change it. You can make a change. You can change it. Let's minimize again, and I will see the effect. Okay, look about this. This is C. This is regarding to the wall for storage. Okay, this C is regarding to the wall for storage. Uh, okay. Do you know? I will give you like a brief. I will also mention in the presentation. But the wall for storage, it means that you already shut in your well, but it doesn't mean that you already shut your reservoir because we are concerning with recording the pressure of the reservoir. But if you're gonna shut in the well, you're shutting the well from the surface, okay? So you have a column, which is the tubing. You have around 5,000 feet, 10,000 feet, depending on your well. So you still have a production from the reservoir into the well until there is a kind of stabilization. This is what we call the well pour storage. The well pour storage. It's related to the well bore itself, and the storage, it means it's a capacity to receive fluid from the reservoir. And it has a negative effect as more as you have a gas. If you have a gas into your reservoir or it's a gassy reservoir and you shut your well from the surface, so it will has a negative effect on the data of the well test because again we told that the management don't prefer long time well tests, so you are limited to a period of time. This will pour storage affect negatively this period of time. Okay, so if we're gonna change this, if I will change, I think you can see a change in the will pour storage. If I gonna change it back again, you will see another change. Okay, so is it okay for you right now? Okay, let's change this line. We have also another line, which is the horizontal line. The horizontal line is mainly concerned with the reservoir. So this line, this sloped line, this is sloped line again. This is sloped line. This is sloped line is already concerned with the wall bore storage. So changing it up and down, it will change the wall bore storage. And this horizontal line is concerned with the reservoir. We normally see if this reservoir is homogeneous and we call it radial flow, you will see this red line, this red recorded derivative coming from recorded pressure. You will see it like horizontal, okay? It shall be like a line horizontal. So we match this to this line, to this red line. Let's imagine at this point. So you can see here is the permeability 13, okay? So if you're gonna change it, if you're gonna make something like this, you will see notice a decrease in the permeability. It will be 6. If you're gonna make it something like this, it will be a higher permeability around 34. Okay, so this is the second step is that to extract your derivative and begin to look and see the relation between this hand aid software black dotted and its matching with the derivative to see just an insights about your parameter. Okay, so let's say the fourth or nearly the final step. It is your model. Okay, normally we have two models in the software: analytical and numerical. We normally don't go with numerical. It has some assumptions, and it's top model trying to mimic the result simulation in some point. And we normally don't use it unless we have like interference test, and we want to account for mapping and our barriers and so on. But normally we go to the analytical, which is this software already is an analytical. It's not a reservoir simulation or something like this. It's an analytical analytical tool. So we normally go, this is let's consider it the final step, which is the analytical. So we will go to the analytical. In this analytical, it will give you the luxury or give you the opportunity to make your analysis because some, let's say Amir coming and say to me, Engineer Karim, I think here it's not a well for storage. I think we have a frac around the well, and this is due to the effect of the frac. And I think in this area, let's maximize. I think in this area, we don't have a reservoir radial flow. It may be something related to the well because the well has a limited perforation. Let's say that we have 100 feet thickness of sand, but we only perforate around 10%. So we call it limited entry. So Amir may debate with me and discuss and told me, so to account for this debate, it's here's the analytical model. Okay, is it okay for you? So we go for the analytical model. It will give you like the opportunity to change your parameters. So as you can see, let's minimize it. You have all of this, okay? Well test is mainly considering with 4 modules. So keep it in your mind. Well test is about 4 modules. The well bore module, which is the well bore storage, the well bore itself, and the well itself, let's say the well trajectory, and the reservoir, which is our main, and the boundary. Okay, time steering is something related to the software. So we are mainly focused on these 4 models. So well test means this well bore, well model, reservoir model, and the boundary. So let's investigate the well bore. Well bore, it means that the well bore compressibility. Normally we go to with constant well bore compressibility. We don't change this with some advanced module, but normally we go with well bore module, which is constant module. Okay, and you can change here. For example, I can put it like 25. I can put the thickness like 100. Okay, I can change it by hand and see. The initial pressure I can change it if I have information about the initial pressure, so I can change it and so on. Skin, well for storage, and so on. Okay. So this is the well for storage. The well module itself, as I told you, Amir may challenge back with me and told me that this well is not fractioned only; it's horizontal, or it's slanted, deviated, or it has some kind of fractures. Okay, so maybe told me it's horizontal. So if you're gonna choose horizontal, as you can see, you will see some other tabs to be open so that you can change. You can here you can see the wall length and so on, and the same for any then slanted. Okay, multilateral. You will see as long as you choose different modules, you will be subjected to enter more data. Normally, also, we don't use such this kind of advanced modules because normally we go for, if you have horizontal, okay, go and make it for horizontal. If you don't have, so let's say that it's a normal vertical well, okay, and here is the data. So this is the second module. So the first module is the well for storage. And as I told you, we normally deal with it as a constant. And second, which is the wall module, normally vertical. And here in the reservoir, you can change between different things. These kind of duals, normally we go for homogeneous, okay? We go for homogeneous and see our data. But if this dual porosity and dual permeability, it is mainly related to carbonate. So if you are working with sandstone, so no need you don't need to use this kind of dual porosity, dual permeability. But if you are working with carbonate reservoirs, you may introduce these kinds of dual porosity, dual permeability, and so on. Okay. And the final, which is the boundary. So you can open your boundary and you can see this boundary is mainly depending on your integration and understanding with other disciplines and your work experience. Because you cannot propose a fault unless there is no fault. So if you know from your structure and if your map and your geologist that there is a fault, so you will introduce a fault. So for example, let's say that we have a fault. Okay, he will ask you what about the distance of this fault, and this fault no flow, it is a barrier, or at different pressure it will give you a flow. So let's say there's no flow and it will give you what is your expected distance. Here you are asking Here, the software is asking about your understanding, not about the interpretation. So the interpretation we will check later. If we have a match, so my understanding and my input is matched with the data. If there is no match, so I will doubt in two ways. I will doubt the data itself, and it has some QC and verification. So if am I okay with the data, so I will doubt myself. Doubt myself. It means that the whole test is saying that we have a fault. Yes, already have a fault, but at not this distance, at around 4 or 3,000. So I will go back to the geologist. Are you sure from your distance from your fault location? He will debate with the seismic or the geophysicist, and at the end of the day, he may tell you something like, oh, we have a doubt about the seismic data. No, we are assured of our fault, so please go and check your data and something like this. Okay. So infinite, it means that you have a very big reservoir. So yeah, you don't have any barrier or something. You may have a leaky fault. Okay, you may have intersecting faults. So if you're gonna introduce intersecting fault, and this is normally happens, so you don't have only one fault. You may have two faults. Okay, so he will ask you what is the distance to the first fault, the distance to the second fault, and what is the angle between the faults. Is perpendicular faults and the wall is between these two folds, or have some kind, maybe let's say 180 or 150, something like opening folds. Okay, so for each module of this, you will see parallel folds. Circular means here that something limited volume. So it's like circular. Your well is in a circular reservoir. It means that it's non-infinite. It is limited. So normally also we go with infinite. So now again, so that I think you began to lose your focus with me. So what we did, we just loaded our data, loaded our pressure, loaded our rate and the pressure, make an extract to see our derivative, make some quick manual check with this two slope line and this horizontal line, and to have a look on our data. And finally, we began to make our analytical model, so that we will tell him, please generate your model to check with these data. Now we will generate, as you can see. So do you see what happens? Okay, so now another thing has been introduced, something like this. This is the analytical model. This red line. We can see that there is very good kind of matching. Okay, and here you can see also. So if I'm gonna change this is the model. Can you see this? This is the model. This is the so I'm trying to match. So if you're gonna match the skin, you cannot match this period. So you may try to match this period, but you cannot match the skin and the wallpaper storage. And you can see here in the corner there is a great gap. So it's something depending on your sense and your understanding. So I will go back again, trying to make something like this. And so again, I will try to fine tune something like this may work. And for any change here, you can see, sorry, I will just adjust something. Okay. So you can see that the parameters here will be changing. And now we can see the more parameters. It's talking about analytical model. Your for storage is constant. We choose well to be vertical, reservoir to be homogeneous, and boundary to be infinite. These are the four models I told you. And here are the data coming from this: pressure, permeability, or transmissibility, permeability, water storage, and the skin. Okay. Here is like another tool. It's not like a step, but you may try it. I normally don't try it, but let's try it. It's called improve. Improve means that he will change the parameters of his analytical black model to match this dotted red line and have, like, let's say, a beta match. So let's try together. Okay, here you give him the data to make that's trials or iterations. So here we could have a change the wall for storage, the skin and permeability. Why he didn't choose H porosity and total transmissibility? Does anyone have any clue why he didn't choose the H. He didn't make iterations on this H porosity and total transmissibility. Does anyone has any explanation why in this kind of improvement he just chose C skin compressible for storage skin and permeability, but didn't choose the H porosity and transmissibility? Why? Can you repeat the question? Okay, Madhu, reservoir heterogeneity? No, I'm saying here again. I told you that normally now we already congratulations, we did a will model, a PPU will model, and we have a data. The other steps like for improving. So I told you that here we have like a tool called improve. So I chose that. Okay, this improve, and I told you this improve will make some iterations trying to change the parameters, the main parameter of the will test to have a better match. So when I opened it, I told you that I can see that he is already ticked, or he already chose the wallpaper storage, the skin, the permeability to make iterations, but he didn't choose the thickness, porosity, and transmissibility. Why? Guys, can you hear me well so far? Are you coping with me? Is everything smooth? Is it challenging or difficult? Because you will be working on this in your internship. We will give you real data of more, maybe one, two, three well test different modules, and you're gonna make an analysis and present it. Yeah, they are not included in the equation. No, they are included. If it improve can increase production. Not that you are right, but it's not in this case. They are not included in the equation. The sickness and the other one is given by lab. I think it's not variable. Yes, that is the right answer because normally you may have a change in H for sure along the reservoir, but let's say in this will we have like a figure out of the sickness, so no need to change it. And also the prostate transferability is a characteristic, so we don't. So we will make it run and see is the result will be improved or not. So here is okay. I can see that yes, there is actually yes, there is like some kind because as I told you, it's something related to your manual judgment. So I change this. I move this line manually by my hand. So it's not a high resolution. I'm sorry for this. Okay, but for this tool of improvement may change. You can see if you can remember the previous permeability, it was around 13. So he just changed it 2 points, but these 2 points made somehow a better match. Okay, so maybe this tool will be useful if you're gonna make an improvement, and the final you can get this is your final results. Okay. I think here something. Yeah, you can see here your all of your results in terms of your input and so on. From this tab, you can see results. Okay. Okay. So right now it's okay. Another important tool which is very good and it will it will deepen your understanding is the sensitivity. Okay, so we can try it. This is a sensitivity. It's a very good tool. Why? Because I'm telling you that if I'm changing the word for storage, it will affect the data. So you cannot imagine how it will affect the data. So let's say we will make a sensitivity on the word for storage. That's just five or let's say three curves. Okay, and here is the minimum and the maximum value, and we're gonna tell him generate. So he will generate different derivatives, not real derivatives. It's from his own, depending on these new values of the word for storage. So as you can see, here is the sensitivity log. You can see so the legend, and as you can see, so can anyone give me an explanation? I'm not sure you can open the mic or not, but if you got what I'm saying, I think you may be able to give me an explanation. Or let me do something else. Let's say that sensitivity, let's say five. Let's say okay, generate. Okay, maximize. What do you think? Here I just increase the number of curves so that you can see the difference. And what I want to say is that please look at the boundaries. Don't care about this in between. Look about this one, this red one, this blue one, and this red one. Which one do you expect has the higher wool pro storage? The red one or the blue line or the blue one? Just to type on the chat. Just to type red or blue. Just red or blue. Yeah, just to type red or blue. And in your opinion, which has the negative effect? Let's ask the question in other words. Which has the negative effect? The red or the blue one? The blue or the red? Just to type red or blue. Okay, I have more than 35 people in the room. So how are you guys? What do you think? Red, red. Muhammad Ahsan red, yes. Anta red, yes. Amir red. That's a great. That's a great. This is the negative effect of the wall compressibility. As you can see, here is this blue line has the minimal or the smallest compressibility. But as long as more as we can go higher and increase the wall compressibility, maybe due to we having get or something like this, so that you can see that it is there's delaying in time. So here this derivative, okay, it's very good. Matching, okay. But for this one, it is very late. It's very late. It's very so the hump is here and our data is here. So it is very late than the actual data, and it is the negative effect of uh, uh, the will pour storage. So let's say that we have another let's say the permeability, and also you'll have five from let's say from 5 to 100, and see what would be the effect. Okay. So let's maximize. So here you can see again. Okay, so can you see it? So as long as I have a lower permeability, I will be here. As long as more as you go to higher permeability, you will have a lower curve like this one. So your curve is in between. So it's something between this blue and this orange, which is between 5 and 29. So this is your data. Going down or higher in permeability, which means going down, so you will not have a match with your data. All of these sensitivities you can check it. Okay. So before leaving the software and give you some theoretical data, which is very important, I want to tell you just one step. So now to recap what we did, just we have already alluded pressure and temperature and alluded rate and the pressure. We already opened an existing project, already alluded rate and the pressure. Then we make our extraction for our derivative and make a visual QC And then we go to our analytical model and choose what we already comfortable with and matching with our understanding. So now we have this screen with our derivative and analytical model, Horner plot, our history data, and the parameters here from the result set. Okay. And as I told you, upon the analytical model, you can use this tool of the improve so that you can improve your parameters for a good matching. And finally, you can make some cases if your manager is asking what is the effect of the variability, what is the effect of the scan, what is the effect of the whole storage on your data, so you can make some sensitivity, and this is a very good tool. Okay. Finally, I want to try to choose the final point in the software is that when we're gonna make like a new project. Okay, so you're gonna choose this one. Let's again, you will here open the software and say new and recent, and here is a blank. You will choose a blank software, blank project, and here is very simple. This is reference. Please don't feel not to change anything here. This is the units, oil field units, and so on. So you can make next. He will ask you to name your analysis. Let's say fifth internship or your team, as long as you will be teams, you will see like team one, team two, and so on, so that it will be no worry, okay? So that you will be able to differentiate. No worry, but I think you missed the software part because I'm about to switch to the theoretical part, which will not take more than 15 minutes. It will be some important notes to keep in your mind. So as you can see, this is not an interference or mini frac. It is like a standard well. This is the name. Well radius, you can see from drilling report what is your final section. Base zone, you can get it from your teammates in geology, let's say 30 or let's say 50 and something like this. And the porosity also you shall get it from your colleagues, let's say 20%. And the depths also you can see it. Okay, so it's tell him next. He will ask you if it's a single phase or multi-phase. Normally we will go with the single phase. If it's gas, call gas. You choose gas. If it's oil, choose oil. And next. We'll ask you about some main parameters for the whole test. Mainly the viscosity is very important and we consider it's constant, let's say zero point 0.3. And the formation volume factor normally for oil is above 1.1 or 1.2 or something like this. Okay, and you have here the saturation of water, which is the condensed water saturation. For sure, it's not zero. So it will be something like 20% or something like this. Okay, and here is the total compressibility. You can check how it's gonna be calculated. It's mainly dependent on the saturation of the three phases of your oil, gas, and water, and your compressibility of the three phases oil, gas, and water, and the formation of compressibility, so that you can have a total compressibility. And like now, everything is okay. Yes, so can start again. There is your units, your naming and your geological parameters, your BVT parameters, which is very important. Okay. And finally, you're choosing your module, which is normally vertical module. Okay. We don't normally use this kind of other softwares. And finally, the four modules I mentioned to you, I told you that these are the most important or the main important four modules for the well test. It's mainly the well for storage, the well model itself, the reservoir model, and the boundary model. As you can see here, normally we go with the simplest case, which is we have a constant well for storage, homogeneous reservoir, finite radius or vertical well, and infinite boundary model. And upon matching, loading your data, making your analytical model, and improving, you will detect if you have differences from these assumptions, if it's not homogeneous, if it's not constant, if it's not finite, if it's not infinite, and so on. Okay. So you will then tell him create. It will take some time to upload. So now you created the project, but you don't have any data. So as I told you, the good thing about the software is starting from top to down. So you load your data first, load your pressure, and so on. So for example, we'll go and load our rate. So tell him load Q, which is the rate. You have many ways. If you have an Excel, load it as Excel. If you have like a text file, load it as text file. So let's try text file. I'm not sure if I have. Okay, so So here we have, okay, we have around, okay, we have good production data. So you can use it. It will be previewed here. So once you are uploaded it, you can see this as hours and time. So you tell him next. Okay. Check that your data is okay. So here is the time and here is the rate of the oil for sure. We are dealing here with oil. Regarding the flow, we are dealing with oil and pressure of oil. So load. You can see this is your production data as you can see. Okay. A long time production and here is like a period of shut-in. Okay. We will go for analysis for sure. I just showed you an already existing project and how to make extracts and so on. This is like a random data to tell you how just to upload your data. So the second one is to upload your pressure. Okay. Again, you can use it as like this, but here you cannot see the pressure is Excel. So go back and choose Excel, and here choose pressure. Okay. Let's open it and see how it's behaved. We can have here data time, liquid rate. Oh, oops, sorry. Okay, let's start with it. Open. Okay, as you can see, he will show you also the data. Okay, see next. And here you need to define the data because as you can see, here is a pressure, here is time. So you shall go here and tell him it is time. So that he can know that this is time, hours. Okay, that's okay. And the go seems like here you cannot see load. So doesn't see load, it means that there's something, some error. Okay, so go. Yeah, so it's pressure. Okay, again. So okay, it is undefined. Here is like hours. Here pressure. Uh, here is pressure. Maybe here is the time. Maximum time. Seems like there is some bug or something because I already uploaded it before the session, but it seems like undefined. Okay, not the pressure, that's one undefined. Oops, pressure, no, undefined. Decimal time. Okay, maybe so that not to waste our time, maybe something, or let's try to load it again. So pressures, next. As you can see here, sometimes no no sometimes as you can see here, just I uploaded it one more time, and it can see that okay, this is time. Here is like time again, pressure, and so on. But okay, so now I can load normally, no worry. Okay, so here, but as I told you, this is just like it's just like a dump data. It's not an actual data. So I just want to here to see you for your first step. If you don't have an existing project, for sure, from our point of view, we will give you as a pressure and production data. You will upload it and you will see something like this module. As this model, you will see something like your data here, this one. You will see something like this. We give you the rate and the pressure so that you will see something like this one, and you will begin to make your extractions and so on. So right now, I believe that 1 hour for software is enough. So I'm gonna stop sharing my screen, and I'm gonna share you something. for theoretical part. Okay. So before switching to the theoretical part, is everything missing? Do you have any questions right now? So guys, do you have any questions? Yes, duration. Yes, duration. Let me check. Yes, maybe points. I didn't notice it. Yes, yes, we can try it. We can check it. Yes. Okay. So I think we have around 10 minutes because we have the webinar 20 minutes from now. So I will go quickly through some concepts in this quick 10 minutes to give you like a brief about the world. So as you can see, here is like uh, I'm not sure you're seeing my screen or not. But is it okay? Can you see my screen? Yeah, I think yes. Okay. So here is like as you can see, it's all about the pressure and rate as we could see in the on the software as and mainly we are dealing about well properties, reservoir properties, and the reservoir panel. That's we already mentioned in the software. And then is the advantage as again I told you in the impulse session to start with the visualization of the software so that you can see the impact of each concept or each parameter on our process. So sorry. Okay, so I'm sorry again. So here is like I want to give you like a flavor. So you are all aware of the productivity index, and I think in the production technology session, Engineer Ahmed mentioned the productivity index and the importance of this one. So what is the relation with will test? Is that the will test will give you an indication about the permeability, which is the spirit of the productivity index. So the will test will give you if this will is behaving good or bad. It will give you like a detailed information about why the wheel is behaving good or bad. On other words, why the wheel has high productivity index or low productivity index. Okay, and the same way for the imbal. The imbal will give you a volume. Okay, the imbal, as we mentioned in our previous session, it will give you like a volume, right? It will give you the volume, as we mentioned, the imbal relate the pore volume to the change in the pressure and the community of the well. So it will give you like a volume. But in well test, it will give you how this volume is distributed. So imbal will give me, I can see 10 million barrels of oil volume. But the well test will give you that this well can see only 2 millions, and the other wells can see only another 2 millions, and so on. So this is very important to link between the disciplines, especially if you are a reservoir engineer and integrating with other disciplines. So you know that integrating with the production technology engineer in the productivity index, you can help him as well, as long as he can help you from his proper model and so on. You can help him as well from your work test model. And also for the material balance, you can help him in determining some parameters like the initial pressure and so on, and tell him that an imbal the imbal can see by reservoir, not by well. So he can see large volume, but for well test, he can give you this well can see kind of portion, and the second well can see a second portion, and so on. Okay. So and here is like this is like before all as you can see this is slides of Engineer Islam. You see Engineer Islam Fawad is our reservoir engineer in OPA Energy, and he is very experienced engineer, and this is his material. So I want to thank him. And this is actually from the wood test course uploaded on our website. It's a very good course. If I invite you to use the discounted coupon in such these kinds of courses like wood test imbalance, so on, it will benefit a lot. So as you can see, we can define the objectives in different categories, like the reservoir limit or the boundary. You can see the distance to the boundary, the drainage area, and so on. Also, you can estimating the average reservoir pressure from the well test. And for reservoir characterization, we are talking about permeability, skin factor, and if we are dealing with carbonated reservoirs, so we are talking about the total porosity. And for well problems or well module, you can also the permeability can give you like an insight, especially if you have a damaged zone, so you can see different permeabilities, and the skin factor, so that you can determine to go with acid stimulation and so on. Here is like stimulation treatment depending on your skin factor. If you already did a frac well, hydraulic frac, so you can determine the frac conductivity and the frac couplings, and these are of such importance to determine after having a frac. So this is the objectives of the well test or the main. But as you can see, this is very important in our reservoir engineering workflow. And another important concept is that well test can be used in all of lifetime of the reservoir, beginning from the exploration phase until our producing stage. For the exploration phase, mainly you are being asked frequently, what is the volume of our reservoir? So we call it reservoir limit test. Reservoir limit or extension. This is coming from the DST. I think you are aware of the DST. So normally when we drill the first well in the area, we make a DST. This DST, it's normally well test. It's like a build-up test. So we use it to have like an imagination about the volume of our reservoir. And as you can see, during the life of the reservoir, we can use it to determine the reservoir pressure, to describe the reservoir characteristic in terms of permeability, and to make some kind of optimization. If this well is damaged, it has high skin, how can we make a treatment? And it is not performing well, and so on. Okay, so as I told you, what about the well test? Um, it's normally like a disturbance. So if the well is producing, so closing the well, we call it PBU. If the well is uh, shut in, so we open it, so draw down, and so on. This is like change. Well test is related to change. It's something. It's mainly related to a change from status to status, and recording this change in a high resolution, so that you can get information about it. Okay. And here is very important point. I think Amir was asking about this, why we use the build-up period, because as I told you, here this area is not a stable rate, because you can see this is the first rate, here is the second rate, and this is the third rate. So that we prefer to have the zero rate, so it's a stable area rate, so you can analyze, as you can see, analyze this. He is advising you to analyze this area, okay? So right now is okay? So another important terminology is the radius of investigation. Okay, the radius of investigation means that this is the radius around the well that the well can feel the change. If there is a change in any parameter, the well will feel it. Okay, so we call it the radius of investigation. And here is a very good comparison between the length of the radius of investigation according to each. As you can see, cores has the least radius of investigation. It's a very small core. Then come logs. Logs has some range of investigation, and the RFT a wider range. And as you can see, the well test is the wider or the longest radius of investigation, because it is like a wave. You are recording a pressure wave. It's something like when you throw something on water, you can see like waves. So these waves will be moving outward. It's called the radius of investigation, and this is also very good concept. And here is what I'm trying to tell you in verbal, that the radius of investigation it's like a theoretical distance within which a limit or any reservoir parameter change can be detected. So here is like your pool. Here's your pool when you can detect or see any change in the parameter. And this radius of investigation is not related to the pressure wave, because pressure wave can go far away from the well. You cannot detect it. But we are detecting the radius of investigation where we can see the change of parameters. Okay. So here is like a puzzle. If anyone can answer it, we are about to finalize just the 4 slides. But what do you think? What We have two wells. Well is producing was 1,000 barrel oil per day, and the other well is five times the production. So, what do you think about the risk of investigation? In which will be higher? Will longer? Will one or will two? Just quickly, you can type one or two. Okay, quickly, one or two, one or two, one, one. I can see Muhammad one, Bilal one, 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 one. Okay, most of you are saying one. So check this. Okay, so the question of the radius of investigation is not related to the rate. It's mainly to the permeability, time, porosity, compressibility, and viscosity. So it's not related to the rate. The rate affects the amplitude, but not affecting the distance of the radius of investigation. So it's like a puzzle. That's why I'm calling it a puzzle. So no relation between the rates. So the same radius of investigation will be for the two wells. Okay, got it? Okay, so let's move to another important part. I gonna finalize with it. So here is getting started, and I think now it's very easy because you're already familiar with the software. So when I tell you that you need to have your rate, pressure, flow properties, reservoir data, you already see that you already saw I can input it in the software, and you can now when I'm asking you what are the outputs, you can tell me that permeability, scan, pressure, description, and so on. So now I think it's now a fit of it. So please take care of this. I mentioned it in initially in the section that please take care of the gauge. Here is the figure shows the derivative curve for the liquid using electronic gauge. This is electronic gauge, high resolution gauge, so that you can see smooth data and you can work on it. But in this one, you can see like a scattered data, not high resolution. It's called Amarada gauge. So you can see this data scattered. You cannot see a trend. You can see here like a cloud, and here is like up cloud and down cloud. So this is very important to take care of. Okay, so please take care of the kids. Okay. Um, sorry, I told you this is yeah, and here is like a common error. You will see here like a common error. Also, these are some of the common errors like. Uh, As I told you, the software, you have to look using your eye to see that the pressure and rate are synchronized. So the pressure is instantly increasing while the production is decreasing. If there's any shift, you need to work on it. Also, you don't have a representing BWF, which is bottom hole flowing pressure, due to noisy or due to something related to the well is not stable. So if you have a wrong BWF, it means that your well is not stable. So you will have you will not have a representing data, and this is very important. Okay, and if you don't have like uh, if you are ignoring some of the production. Yes, depending on your data, if you have so much noisy data, so it may be not representing at all. Okay, but yes, but if you have some missings, or you can, this is a kind of smoothing. If you so that I can make a smoothing and neglect it. So if it's just one or two data scattered, but if it's large data, so it means that these data are affected, and we report that this test is not valid anymore, and we want to repeat the test or choose another well that is able to make our test. The last two slides will be this one also. It's worth to mention. It's something advanced, but it's good to know about it. Is that if we have multi-layer reservoir, we normally don't prefer to make a test for multi-layer reservoir. Multi-layer means that you have two reservoirs, layer one and layer two. Because if there is a difference between these two layers, difference in production, difference in pressure, so you may not be able to perform the well test because let's say that you are shutting the well and this layer is stable with the gauge, but this layer is still having production or taking production from this well, depending on the pressure performance. So that you will see something like this. So you may come and say, oh, why I can see this down flow from up to downs. I can see why I can see this kind of data in this. You can see this. I'm not sure the lighting or the color, but you can see here some down derivative, the points of derivative. You cannot analyze them. So the only way, yeah, I'll wrangle by data analysis before it is the job. Yeah, it's the job of the two people. The data the data dumping engineer to make a QC or check that the gauging was working okay, the memory is okay, the data is good. Normally it's memory data. It's memory data normal, yes. So to check and check, normally check and they give you the data. Then you make another check when you upload to software, so you can see yes, this is the actual test of the well, and this is the actual time and so on. Okay, so it's something advanced, but I just wanted to tell you, uh, and here is like the final thing is that I think I showed it the effect of the well for storage. As you can see, here is the red here is the red lines, which is the normal shutting the well from the surface. So you have a very long time due to the effect of the well bore storage until you have the reservoir signature. However, there is a new technology right now is to making shutdown from downhole, running hole with like a backer or something like this to shut in from the downhole, so that minimizing the well bore storage effect and you see the response of the reservoir. I'm sorry, I'm talking quickly at this last 10 minutes because it's only 7 minutes to start our webinar. So guys, thank you very much for such this for me, such your commitment. Hopefully, we are about to arrange the teams and distribute the data. We are just waiting for the BPT. You have now you have a session in drilling, and we have just only remaining one session for the BPT, and we will start working from this week. Maybe from tomorrow or maybe from today to tomorrow, we will make team formations, 10 teams with 10 different names, and for each team, you will have a leader from yourself and a moderator from our side. Okay. And after that, we will distribute the data and what are the requirements from data. Data will be BPT, Imbal, will test, modeling, and will logs for formation evaluation, and trying to have like a drilling problem. So you will be required to make a complete evaluation. Okay. I'm sorry, I will not let time for questions. If you have any questions, you can use the group. I will ask Enji Adel to open the group for questions, and he will send you the feedback. Please, it's very important to fill up the feedback. Right now, I will sorry close the session. Okay, and hopefully I will share you the link of the webinar. Please try to attend. I know it is something headache to attend many sessions together, but try to attend as much as you can. Okay, thank you.